Okay guys, we're doing section 6.2 today. We're going to be solving systems of equations with the substitution method. Yesterday we learned how to solve systems with by graphing. So if you have a system like y equals 2/3 x minus 1 and y equals 5x, let's say minus 1 as well, then that system is really easy to solve by graphing. Why? Because they're both in slope-intercept form. As a matter of fact, we know that both of them cross the y-axis at -1. That's the point that they share, so the solution would be 0, -1. I solved the system just by thinking about their graphs. Really easy to do. But some systems are not ready to solve by graphing. Some of them are ready to solve by substitution. So let's move on to the notes on substitution. We have our notes right here, and of course it has a class opener. So let's begin with the class opener. We're going to review what we did yesterday, solving systems by graphing. And as you can see, both equations are in slope-intercept form. Not only that, both equations have the b value of -3. So if I were to graph the top equation in red, it crosses at -3. And from that point, my slope is 2/1. So I'd have to go up 2/1 and put a dot right there. And I could continue to go up 2/1, up 2/1, and there's my line in red. Put arrows on it because it does continue forever. Now if I wanted to graph the bottom one in blue, it also crosses at -3 at the same exact spot, but this slope is different. It's -1/1. So I'm going to go down 1 and over 1, down 1 and over 1. So if I wanted to extend the line backwards, use the same pattern but backwards, and you'll get that blue line right there. So again, a review from yesterday. What is this red line? What does it represent? It represents every single answer that exists to the red equation above, or the top equation. What does the blue line represent? It represents every answer that exists to the bottom equation. Now, since they're asking us to solve the entire system, we want to find the answer that works both for the red and the blue. So if we have these answers, which is the one answer that works for both? The point of intersection. So that point of intersection is 0 for x and -3 for y. To be honest with you, I didn't even have to graph it. If I already understand y equals mx plus b and y equals mx plus b, I already know that they're different slopes, and I know that they're the same exact b value, which is the y-intercept. So I know that they cross at that point. I know my answer. Likewise, if they're in y equals mx plus b and you notice that they have the same slope with a different y-intercept value, if they have the same slope, that means that they're parallel. That means that it would be no solution. So sometimes systems are really easy to to solve by graphing. But there's other situations where it's not ready to graph, and it might be better to use a different method. This second method that we're learning today is called substitution. We're also going to learn a third method next week, which is elimination method. As a matter of fact, I made a typo here. So let's all go down to this part right here. It says, or number 2 above. There is no number 2 above. So please scratch that out for me. I'm sorry. I should really edit that. But scratch that out for me because there is no number 2 above. But this system that we give you down here, this one's not ready. Well, the top equation's ready to graph, but the bottom equation's in standard form and not ready to graph. So we could switch this to slope-intercept form by subtracting x, and rewriting it, and then dividing everything by 3, and then we could graph both. But let me tell you something here, guys. Graphing is not the best method. Okay, graphing is not the best method, especially if you don't have graph paper. So if somebody gave me this problem, I don't have graph paper here, I would not use graphing. I wouldn't change it to y equals mx plus b and graph the lines, because if you don't graph it perfectly, you're not going to find that exact point of intersection. So in this situation, it's better to use the substitution method. Let's show you what the substitution method is. Down here, it has detailed steps on how to do it. So step 1 says pick an equation and solve for a variable. It's the same exact system that you had above. So if it says pick an equation and solve for a variable, obviously pick the equation that already has a variable by itself. Like let's say both of them were in standard form. You'd have to either solve for y or solve for x, but right here y is already by itself. It's already solved for y. So this is step 1, picking this top equation. Okay. Number 2, substitute that variable expression. Okay, this is an equation, but when I say variable expression, I'm talking about the variable expression that y actually equals. Okay, so what does y equal? Y equals 2x minus 3. And we're going to substitute that variable expression, 2x minus 3, into the other equation that you have not used. Okay, so we already picked the top one, we haven't used the bottom one. We're going to take this variable expression and plug it into the bottom equation right here into the y. Why are we plugging it into the y? Because y equals this. Y is this. So if y is that, let's just substitute that into the y. I hope that makes sense. So I'm going to draw an arrow, and I would like to see arrows when you guys show your work right here. So my new equation on the bottom is going to look like x plus, but instead of 3y, I want to put 3 parentheses equals 12. Okay. Now inside those parentheses, I'm going to actually plug in the variable expression from the above equation, which is 2x minus 3. And guess what, guys? We have now a single variable equation that we could solve for. See, there are no more y's, they're just x's. And when you have a bunch of x's, you could actually solve the equation for x. So we're going to now distribute 3 times 2x, and we'll get 6x. And then 3 times negative 3, we'll get negative 9. And let's bring down everything. We still have the equal sign, we still have the 12, we still have the plus sign because that's a positive 6x. Bring down the x out in the front. And now we have 3 terms on the left side of the equal sign. So here's the equal sign, there's 3 terms over here. We could combine the first 2. X plus 6x, that is 7x. Bring down the minus 9, bring down the equal sign, and the 12. You have now a 2-step equation that we need to solve. Again, you want to get x by itself. X is the movie star. Let's get rid of that bum at the corner. If you're my student, you know what that means. We're going to get rid of that minus 9 by doing the opposite, plus 9. Cancels out. What you do to one side, you do to the other side, plus 9. And we get a new equation, 7x equals 21. Final step would be to get rid of this multiplication of 7 in front of the x. To get rid of something, you do the opposite. The opposite of multiplying is dividing, so you do a division bar. Put the 7 there, put the 7 there, and we will have 21 divided by 7, which is 3. Okay, so x equals 3. You're probably thinking, I'm done, I have the answer. Well, technically you have half of the answer. What the heck does that mean, half of the answer? Remember, when you're solving a system that involves x and y values, you need to find the x value and the y value. So what do we have so far? We just have the x value of 3. Okay, so that's where we move on to this fourth and final step. I kind of didn't follow along with the steps, I'm sorry. So step 1 was to pick an equation and solve for a variable. We picked the top equation because y is already by itself. Step 2, substitute that variable expression, this guy right here, into the equation you have not used, which is the bottom one, so you plug it into the bottom one. Why am I plugging it into y? Because it says y equals that stuff. So y is that stuff, so we plug in that stuff right there in for y. And then number 3 says solve the equation. We actually did that. It says get an actual answer. We did that. We got x equals 3. Now what does it say? It says and substitute. That's where the word substitution comes in on the title. And substitute it back into any original equation and solve for the other variable. So again, we have half of the answer. We're going to take that answer, plug it in either to this x or to this x, any x you want, and solve for the other variable y. So I'm going to use the top equation. The top equation reads y equals 2x, but instead of x I put parentheses, minus 3, and of course I'm going to plug in this x right in there into the parentheses, which is 3. So I really have y equals 2 times 3, which is 6, minus 3, and 6 minus 3 is 3. So my equal sign comes down, my y comes down, y equals 3. So what is my answer to the original system up here? X equals 3 and y equals 3. If I were to have graphed both the top equation and the bottom equation on graph paper, I would see that both lines intersect at the coordinate 3, 3. So you have these steps right here to help you out. All we have to do is practice. If you understand it, that's great. But if you don't practice, you're not gonna be able to truly master it. So let's practice. Let's do this one. You guys follow along with me, please. Step 1 is to pick an equation and solve for a variable. So there's many roads to the same place. Of course, if you want to get somewhere, you want to pick the quickest path, especially if you're on a time limit here. So would it be easy to get x by itself? Well, I'd have to subtract 3y, and then after that, I'd have to divide by 4. So that's 2 steps. So would it be easy to get y by itself? No, I'd have to subtract 4x and then subtract 4x and then get rid of the multiplication of 3 by dividing by 3. That's 2 steps also. So I want to move on to my bottom equation. This one is easy to get x by itself. Why? Because all I have to do to get x by itself is subtract 5y. So there's always decisions to be made. I'm going to be subtracting 5y here, subtracting 5y here. And now I have x equals negative 5y minus 9. Ladies and gentlemen, I have done step 1. Step 1 says pick an equation and solve for a variable. I did that. I picked the bottom equation and I solved for x. That's step 1. Step 2 reads, plug in that variable expression into the equation you have not used. Okay, now what variable expression? We have an equation, don't we? Yeah, it says x equals this stuff. That's the variable expression that I'm talking about on step 2. So you're going to take that stuff, x equals that stuff, you're going to plug that stuff into the other equation you have not used. We have not used the top equation. So what am I going to plug it into? Am I going to plug it into the y or into the x? I hope you say x because that's where we plug it in. Okay. Why are we plugging this stuff into x? Because it says x equals, right? If it were to say y equals some stuff, then you'd plug it into y. But we decided to solve for x, so we're plugging it into x. Anyhow, we are now going to show our work again by drawing arrows. When I plug it in, I'm going to end up with this. I'm going to end up with 4. Instead of x, I'm going to put parentheses, and then plus 3y equals negative 2. Now, in the parentheses, I'm going to be plugging in this value, this algebraic expression, variable expression, negative 5y minus 9. Negative 5y minus 9. And now, I have a single variable equation, right? I have an equation that only has y values, no more x values. So let's start distributing. 4 times negative 5, that's negative 20 with a y. 4 times negative 9, that's negative 36. Bring down the plus 3y, bring down the equals, bring down the negative 2. You rewrite everything, right? Once again, from semester 1, how do you solve an equation? You simplify each side first. So what does simplify mean? It means distributive property and then combining like terms. So I've distributed, now let me combine like terms. We have the first term that's alike with the last term on the left side of the equal sign. So if you owe somebody $20, have $3, you're still going to owe them 17 of those dollars. Bring down the minus 36, bring down the equal sign, bring down the minus 2. Let's continue solving here. I'm going to get rid of the minus 36 by going plus 36. What I do to one side, I do to the other side, plus 36. I'm going to rewrite what I have. I have negative 17y equals 34. And now for my final step, I need to get rid of that negative 17 in front of the y that's being multiplied, right? So how do I get rid of multiplication? I do the opposite. I do division of that same exact value. So divide by negative 17, divide by negative 17. And luckily, y equals negative 2. You could use a calculator if you want. But what I have here is one answer. And on step 3, it doesn't say just plug it in. What does step 3 say? Let's go back to step 3. It says solve the equation. I already did. I got an actual answer. Now I need to substitute that answer back into any original equation and solve it for the other variable. Okay, so I already plugged it in. I already got an answer, y equals negative 2. I need to now substitute it back into any original equation to solve for the other variable. So it's up to you. Do you want to plug it into the top equation or the bottom equation? Whatever you like. I want to go with the bottom equation. It looks a little bit less complicated. So on the bottom equation, I have x plus 5y, but instead of y, I'm putting a blank spot, equals, or parentheses, equals negative 9. So in the parentheses, I'm actually going to take that negative 2, put it right in there. That's a negative 2 right there. Let's do some math again. So x plus 5 times negative 2, that's really x plus negative 10, or minus 10, whatever you want to write. Plus negative 10 or minus 10 is the same thing, equals negative 9. So now I'm going to solve for x by adding 10, canceling, adding 10, and I will get x equals 1, because negative 9 plus 10 is 1. X equals 1. So what's the answer to the original system that we have over here? The answer is 1 comma negative 2. Okay, 1 comma negative 2. That's my answer. 1 comma negative 2. X equals 1, y equals negative 2. Now, if you're taking a test, it'd be a great idea to plug in 1 for x, negative 2 for y, and see if it really does give you negative 9, which it does. Also plug in 1 for x up here, negative 2 for y right there. 4 times 1 is 4. 3 times negative 2 is negative 6. 4 plus negative 6 really is negative 2. So you could double check every single answer that you get on this section of solving systems. All you have to do is plug it in and see if it works. Double check it. Okay, so I want you and a partner, whoever's sitting next to you, work on this together. Hopefully you paused it and then try to do it. Step 1, pick an equation and solve for a variable. So if you pick the bottom equation and you're trying to solve for x, honestly, I mean, you're just making life a lot more complicated on you. The easy one to pick is the top one, and you're going to solve for y. Why? Because it's already solved for y. It already has y by itself. Remember, solve means get that variable by itself on one side of the equal sign. So step 1 is done for you. You're picking the top equation. Get the letter by itself, it's already by itself. Step 2, plug in that variable expression. Again, if you're thinking, wait, that's an equation. Yeah, but it says y equals this stuff. That stuff is a variable expression. Plug it into the equation you have not used. You haven't used the bottom equation, so we're going to plug it into the bottom equation, and we're plugging it into y. Why am I plugging it into y? Because it says y equals this stuff. Here's y. Y is equal to this stuff, so plug in that stuff into that y. If it would have said x equals, then I'd be plugging it into x, but it says y equals, so I'm plugging it into y. And I like drawing arrows. I hope you guys do arrows as well. So what we have here is a new equation on the bottom. It's going to read 2x minus 3y, but remember we're plugging in something into y, and that's going to be equal to negative 4. And we are plugging in the negative 3x plus 16 into that y. So let's put negative 3x plus 16 right into that y. And now what we have here, ladies and gentlemen, is an equation with one single variable. There are no more y's. It's all about x's. So let's solve for x. How do we solve equations? We simplify first. Let's distribute first. So I'm going to distribute this minus 3. Minus 3 times negative 3x is positive 9x. Minus 3 times positive 16, that's negative 48. And bring down the 2x that's in front, bring down the equal sign, the negative 4, and we have a new equation here. You already did distributive property, now let's combine like terms. What is 2x plus 9x? That is 11x's. And I still have the minus 48, we still have the equal sign and the negative 4. I need to get rid of that minus 48 by doing plus 48. It's going to cancel, plus 48. 48 with a negative 4, or a negative 4 plus 48, you will have 44 left over. Positive 44, that is. And of course, the 11x comes down. And for my final step, I divide by 11 on both sides, and that's easy. X equals 4. Sorry about that. Let me see. X equals 4. Now, we have one answer, and we still need the other answer. So again, step 3 is not only to solve and get an answer, but you take that answer and plug it back into any original equation. The easiest one to do would be to plug it into this top one. Negative 3 times 4 is negative 12, and negative 12 plus 16 is 4, so y would equal 4. But let's just say you don't want to go with the quickest route. Let's say you wanted to pick the bottom one. It doesn't matter which one you actually pick. You could pick the bottom one. Let me actually substitute the 4 right here right into the x. So I would have 2x, which is 2 times 4, minus 3y equals negative 4. Okay, so 2 times 4 is 8. 8 minus 3y equals negative 4. You could get rid of the 8 by subtracting 8 on both sides. I will have negative 3y equals negative 12. And if you divide both sides by negative 3, divide by negative 3, you will get y equals 4 as well. So the final answer to this system is 4, 4. 4 on the x, 4 on the y. Now if you were taking a test and you have some time left over, take that 4 and take this 4 and plug it into the x and into the y. And also take it and plug it into the x and plug it into the y and see if it does give you a true statement, which it does. Another thing, or another observation, or another thought you could say is, if I were to graph this on an XY plane, and if I were to rewrite this in slope-intercept form and graph it as well, both lines would intersect at the coordinate 4, 4. So let's try this one right here. If you're at home, please pause it. Try to do it on your own. If you're in class, pause it and work on it with the partner. Here we go. Hopefully you did pause it, because I'm going to start with the explanation. Let's pick one and get a letter by itself. Which one's the easiest one to pick? It looks like the bottom one's the easiest one to pick. And it's easy to get x by itself because it's just done with one step by getting rid of that plus 3y by subtracting 3y. What you do to one side, you do to the other side. So we have x equaling negative 3y plus 3. That is the bottom equation solved for x. The next step is to plug in this variable expression that x equals and plug it into the equation you have not used. We haven't used the top equation, so we're going to plug it right into the top equation into x. Why am I plugging it into x? Because it says x equals, right? It says x equals that stuff, so we're plugging in that stuff into x. If it would have said y equals, if I would have solved for y, then I'd be plugging in this stuff into y if it would say y equals. Anyhow, I like drawing arrows. Let's continue drawing arrows. 2x, but instead of 2x, I'm going to put 2 parentheses. And in the parentheses, I'm going to put negative 3y plus 3. And then we have plus 5y equals negative 5. So what we have over here is a single variable equation that we could solve. Let's distribute 2 times 3y, that's negative 6y. 2 times 3, that is 6. Bring down the plus 5y, bring down the equals of negative 5. And we will have our 3 terms that we could combine on the left side. There's only 2 out of the 3 that we could combine, the negative 6y and the positive 5y. That's negative 1y. Bring down the plus 6. Bring down the equals. Bring down the minus 5. We have 2 steps to go. Let's get rid of that plus 6 by subtracting 6. Subtracting 6. We're going to have a new equation that reads negative 1y equals negative 11. Final step would be to get rid of that negative 1 that's being multiplied by y by dividing by negative 1, dividing by negative 1. So y equals positive 11. We have one answer, we need the other. So we're going to take that y value of positive 11 and plug it in and solve. So I'm going to take the y value of positive 11 and plug it into the bottom equation right into y. Why? Because y equals 11. So my new equation on the bottom is going to read 8x plus 3y, but instead of y, I'm plugging in an 11. 3 times 11, put that in parentheses, equals 3. So we really have x plus 33 equals 3, and we would have to subtract 33 on both sides. Subtract 33 on both sides, which tells you x equals negative 30. And your final answer to the entire system, write it as a coordinate. That would be an x value of negative 30 and a y value of 11. Now this is a great system that shows that graphing is not always the best, even if you have a 10 by 10 graph paper, because on the 10 by 10 graph paper, these lines will not cross. You won't see them cross. It crosses way outside the graph at negative 30 on the x and positive 11 on the y. Moving on down here, it says you do it alone, but if you need help, ask someone. Solve using any method you like. So you could graph it if you wanted to. You could substitute if you want to. Obviously, we want to practice substituting. But if 2 of them are really easy, ready to graph, then you might as well think about their graphs. Anyway, right here, I'm going to use substitution method. Step 1 is to get a letter, pick an equation, get a variable by itself. It's already done for you. The next step is to take that variable expression, that y equals, and plug it into y on the equation you have not used. And then we have a new equation that'll read x plus, but instead of y, I'm going to put the x minus 3 from above. And of course, it's still equal to 5. So let's distribute. Actually, there is nothing to distribute. There's a plus sign. If you distribute a plus sign, nothing changes. So in reality, we don't need those parentheses. X plus x minus 3 equals 5. So that's really 2x minus 3 equals 5. I need to get rid of that minus 3 by going plus 3 to both sides. I will have 2x equals 8. Final step will be to divide by 2, divide by 2. By the way, if I'm working too fast, it'd be a good idea to pause it on each step, and then you keep going if you're trying to keep up with this at home. So our final answer is x equals 4. That is an answer. But we need the other answer. So how do we find the other one? If you know one of them, plug it in to any one you want and do the other. So it'll say y equals 4 minus 3. I already know that the answer is 1, but I'm going to write it. Y equals 4 minus 3. See, I plugged in the 4 right into the x. So I have 4 minus 3 instead of x minus 3. So that tells us that y equals 1. So what's my answer? X value is 4, y value is 1. If I were to have graphed it, they would have intersected at the coordinate 4, 1. Let's move on to number 5. This is really easy to substitute. It's so easy, some people get confused. They don't know what to do. It already has half of your answer. It tells you x equals 2. So all you need is a y. Just plug it in right there. 2 times 2 plus 3y equals 7. That's going to be 4 plus 3y equals 7. Subtract 4, subtract 4. You will have 3y equals 3. Final step would be divide by 3, divide by 3. Y equals 1. So we have the x value of 2. That was given to us up here. We have the y value of 1. That is your answer to that system. If you were to graph both of those equations, they'd cross at 2, 1. Number 6, you could take this variable expression and substitute it into here and get a new equation that reads 6x minus 3 equals negative 2x minus 3. And then you could solve this equation. But hold your horses. Why do I say that? Because both equations are in slope-intercept form. So I could already visualize the graphs. I already know that this one crosses the y-axis at negative 3 and it goes up 6 over 1. I know that this one also crosses at negative 3 and it goes down 2 over 1. So if I know that they both cross the y-axis at negative 3, let me do a quick sketch. 1, 2, 3. The top one crosses at negative 3 and it goes up 6, way up here over 1, so that's a pretty steep line. This is just a sketch. The bottom equation crosses at negative 3 as well and it goes down 2 over 1. So where do they cross at? They share that coordinate. What is that coordinate? The coordinate is 0, negative 3. I'm done. That's my answer. I didn't have to do any math. Now I could continue with this. I could continue with the substitution method. And I could solve for x, but I already know my x is going to equal 0. And then when I plug it back in, my other answer is going to be negative 3. So sometimes graphing is easier. Okay, so at the beginning of this video, I had my quiet voice because I was alone in class. I was talking like this. That's really weird. But now I'm in front of you guys, so I apologize for the change in voice if you're watching this video for the first time. Let's jump to number 7. Number 7, step 1 on substitution. Since they're not in y equals mx plus b, I'm not going to graph them. So I'm going to do step 1 in substitution, pick an equation and get a variable by itself. So what would you pick? The second one, and what do you want to get by itself, x or y? X. So I want to get x by itself by doing the opposite of minus 2y, which is plus 2y. That'll cancel out. What you do to one side, you do to the other side, plus 2y. My new equation will read, solving for x, x equals 2y plus 4. Okay, so what I do now is step 2, substitute that variable expression into the equation you have not used. Which one have we not used? Top one. And I'm going to plug it into either the x or the y. Which one? The x. Why am I plugging it into x? Because it says x equals. That's right. If it said y equals, I'd be plugging it into the y, but it says x equals, so I'm plugging it into the x. Anyway, my top equation is now going to look like 3, but instead of x, I'm going to put 2y plus 4. It's still going to read plus 4y. It's still going to be equal to 2. So again, I am substituting the 2y plus 4 right in there. And now we could zoom in to this equation, this new equation, because it's now a single variable equation. All I have to do is get y by itself. And of course, you're going to distribute first and then combine like terms. So distributing 3 times 2y, that's 6y. 3 times 4, that is 12. And bring down the plus 4y, bring down the equal, bring down the 2. After that, let's combine like terms. The 6y and the 4y is 10y Bring down the plus 12, the equal sign, and the 2. Let's continue solving here. What do I do next? Close? Subtract 12. Subtract 12. We will have 10y equaling negative 10, which means that when I divide both sides by 10, what do I get as an answer? Y equals negative 1. So I have my y value of negative 1. I still need my x value. What do I do to find my x if I already have y? You plug it in. Which one would you like to plug it into, the top one or the bottom one? The bottom? You guys want to do the top just to do things backwards? Okay. Let's go with the top one, just for funsies. Yeah, the easiest option is to plug in the negative 1 right here, right? Negative 2 times negative 1, that's positive 2. So you'd have to subtract it. Subtract 2, you'd get 4, take away 2, so you get your answer x equals 2. I already know that my answer is x equals 2, but just for funsies, I'm going to use the top equation this time. 3x, just to prove that it'll work anyway. 3x plus 4 times negative 1 equals 2. So there's the negative 1 that I'm plugging in. It's going to read 3x minus 4 equals 2. And if I add 4 to get rid of the minus 4 to both sides, I'll have a new equation. I should have done the easier one, huh? Sorry. 3x equals 6, which means that if I divide both sides by 3, you'll get x equals 2. Yeah, I always pick the shortcut. Anyway, our answer is 2 comma negative 1. If I were to graph both equations, change them from standard form to slope-intercept form, I would have two lines that would intersect at the coordinate 2 comma negative 1. Number 8. Which equation would you pick for step 1? The top equation or the bottom equation? Top one. Perfect. X is by itself. Let's get that variable expression of 2y plugged into the equation we have not used. And we're going to plug it into x because it says x equals. So 2y is going to go right in here. So my new equation is going to be over here. And it's going to say negative 2 times x plus 4y equals 6. Now the x value is 2y. I'm plugging it in. So let me distribute, combine like terms, and then solve. So I'm going to multiply negative 2 times 2, that's negative 4y. Bring down the plus 4y equals 6. Weirdness. What happens?
0.
Combine negative 4y with positive 4y, they cancel out.
0.
0 equals 6. What do you guys say when we have 0 equals 6? You say no, as in no solution. That's right, no solution is the correct answer. No solution. So this is kind of like back when we were solving just regular equations. If your variables completely cancel out and you're left with something that's impossible, like 0 equals 6, you say no solution. But let's say the variables cancel and you end up with something that's always true, like 6 equals 6. Oh, I'm sorry, 6 equals 6. Then you wouldn't say no solution. Right there you would say infinitely many solutions. All right? Let's take a look at number 9 over here. Step 1, pick an equation, solve for the letter, solve for a variable. First one's already done for you. So substitute that variable expression into the equation you have not used. Let's take that x plus 2 and plug it into the x or to the y? Into the y. And when I plug it into the y, it's going to read x plus y, but instead of y, I'm putting parentheses, equals 6. Inside of the parentheses, we're substituting the x plus 2. Now, notice that the parentheses aren't even necessary because there's nothing to distribute. I mean, if you had a minus sign, you'd have to distribute the minus sign. But there's a plus sign, and distributing the plus sign doesn't change anything. It's simply going to be x plus 2 equals 6. So 2x plus 2 equals 6. And then I solve, subtracting 2. I will have 2x equals 4. For my final step, I'd have to divide by 2, x equals 2. I have one answer. I need my other. What do? Plug it into the other, right? So where am I going to plug it into, the first or the second? First. All right, so I have y equaling x plus 2, and we're plugging in that x value of 2 right in there, which means that y equals 2 plus 2, which is 4. There's my other answer, written as a coordinate. 2, 4 is our final answer to that system. If you have extra time on a test or quiz, plug in those values back into the system to see if that you could double check it, that it works for both. I want to do one more, even though it's not on here. Maybe you want to jot this down in the back of your notes or somewhere. So let's say we have this system right here, and they ask us to solve it. We're going to do substitution. We're going to pick an equation. Let's pick the top one, right? And let's get the variable by itself. If I get the variable by itself, the x by itself, I would have to add 5y and add 5y, and I will have x equals 5y plus 10. Everybody with me? What do I do now? I take that variable expression, the 5y plus 10, and I'm going to plug it into the equation we have not used into the x. So my new equation will read 2, but instead of x, I'm plugging in the 5y plus 10 equals, actually no, minus 10y equals 20. Right? I rewrote 2x minus 10y equals 20, but instead of x, I put the parenthesis and plugged in the x value right in there. Now we're going to distribute and combine like terms. When I distribute, 2 times 5y is 10y, 2 times 10 is 20. Bring down the minus 10y, bring down the equal and the 20. Combine like terms, and what happens with those 10s? With the 10y and the negative 10y? They cancel out. So what do you have left? 20 equals 20. What do you guys think about that? That's always true, which means infinitely many solutions. Now, if it's impossible, you say no solution. If it's always true, you say IMS, right? But of course, you need to know what that stands for, infinitely many solutions. Now, what does that mean visually? If I were to graph the original standard form equation and graph this one, change them both to slope-intercept and graph them, guess what? They're going to be the same exact line. They're going to land right on top of each other. They have an infinite amount of points in common. All right? So this video is way too long, but I did want to explain those special cases. So we have everything you need to know about solving with the substitution method. Again, you could solve by graphing if it's ready to graph, but I don't recommend it.